Systems of inequalities, almost like a bonus lesson, like a breathing, easygoing assignment after what has been really a set of intensive, computational heavy substitution, elimination. We get this lesson. This is a lesson we're actually going to do twice this year. Once now, because I think it relates perfectly to what we've been doing, and then once again at the very end of the year as a preview of the beginning of Integrated 3. So let's dive in. Make sure you have your Desmos calculator up. It's going to be especially helpful today. And we're going to start by learning a few things that I am going to show you on this calculator. Once the internet loads. There we go. All right, do we need those functions up? You see two graphs here. Now, reminder, we've learned for the last few assignments that anytime we have two lines, the point where they cross is going to be your solution to the equations that form these lines. So with inequalities, inequality means greater than, less than, it also means greater than or equal to, or less than or equal to. Instead of finding where the lines cross, we're going to care about where the shadings cross. What do I mean by shadings? Well, that's what I want to show you in this calculator. So if I type in y equals 3x plus 2, there's my equation. Could even zoom in a little more to make it even more obvious. So this is a line with a positive slope of 3, meaning you go up 3, over 1, up 3, over 1, all the way up, crossing at the point 0, 2 for your y-intercepts. That's why you have this plus 2. Well, if I make this equal sign a greater than sign, watch what happens. This line stays in the same spot, but now it becomes dotted with this shading above. All right? If I go backwards and make it a less than, then it's a dotted line shaded below. Why dotted? Well, because it doesn't include the less than or equal to sign. Let's remind ourselves what happens when I use that. So down here, we have these 4 inequalities. I could type that one, less than or equal to. It's still shaded below, but now we have a solid line because it includes that line. Same thing with greater than or equal to. If we have greater than or equal to, it's a solid line shaded above. Now, we're going to have two different equations, and we're going to find where the shadings overlap. Right off the bat, I see I have two equations that don't have the equal to lines on them, so they're going to be dotted lines, and let's see what they look like. So greater than, I can use the slash next to the right shift key to put in my fractions. So 4/5, again, the shift right key, look right next to that to the left of it, there's a question mark and then a little slash. Use that slash for fractions. And then y is less than 5 over 4 x minus 1 over 4. So purple and green are among my favorite colors, but they're not good for this assignment because the overlap is going to look very similar to the non-overlap. Thus, pay attention and click the buttons I'm about to click. It's going to make this assignment so much easier. Go up and use this gear button that we used for the tables before. All right, hit that. Once you do that, you can actually change the color of these lines by clicking on the colors themselves. I want to make sure that one of these is blue and one of these is red. All right? That's very important. Once you have one blue and one red, hit done. And then to complete this process, we are going to click on the blue one. When you click on the blue one, you will see some primary school color knowledge returned to you from many years ago, which is that if we mix red with blue, we get purple. And all we have to do is match up the purple with our graph. Like, look at this first one. This dot here is at the point 1, 1. And I could click on this dot, and sure enough, 1, 1. This shaded to the right matches the purple. So for me, and maybe I'm guessing for you, it's probably the first graph. And let's make sure that none of the other ones look the same. Shadings above here. Nope, it's not where the purple is. Shadings on the left with solid lines. Nope. Left again. Bottom. Top. It's got to be the first one. And that's what we do for each one of these. Make sure one's blue, one's red. Where is the purple overlapping? Number 2 is another one that's not going to have any solid lines because there's not the equal to equations again. And let's now replace, just leave these up and just replace your fractions, your slopes, and your y-intercepts so that hopefully they stay the same colors of blue and red and we don't have to change them. If they change, we'll change them back. All right. Remember to focus on the blue one. So I'm going to click on the blue. There's the purple. It returns to me. And this is another one that looks like it might be the first one. The 0.23. There's 2, 3. Yep, shaded on the right, both dotted. That's probably the first one again. This is up. This is left and all solid lines. Left, down, up. No, it's got to be the first one. All right, so the first 2, I got the first one for them. If I remember right, you might have the same thing. You could pause this right now and just try doing this next one on your own and maybe go in from here on out until you maybe find a spot that you need help with. And then you could fast forward this video. I'm just going to go over each of these one by one. For the audience at home who maybe doesn't have problems and is for some reason just wants some math problems to do this morning. All right. The overlapping here is once again on the right and dotted, so we know it's not the first one for the first time. This is solid lines with the above region. Instead, this is getting closer, but we want the right side. Like there. And a reminder what's going on here. So we have greater than our negative slope. Our negative slope's going up to the left, so shaded above. That's this blue part. And then less than 1/2 x. That touches at 0. It's got no other y-intercept, and it's less than, so it's shaded below. That's this red part. The overlap is the purple. So if you ever have to manually do this or look for this on a test, that's what you're looking for, that overlap. It's the lines and the equations you know, just with inequalities and shading. All right, finally on number 4, we have an equal to equation. So less than or equal to x plus 1. And then I've got greater than negative 3x plus 5. And I'm going to focus on the blue one. All right, so I've got now one solid line going up and to the right, a dotted line up and to the left, and the purple is going to be on the right. So the opposite of what's going on the first one. The opposite of that. This is the correct little setup, but it's not in the right shape. Boom. This one's good. We could even check our point. 1, 2. Is this the point? 1, 2. Yep. It's definitely this last one. Don't match up just by color. Be nice if they were all purple, but they didn't know that we were going to be using this online calculator and doing a red and blue overlap, so that's not on them. All right, finally, 2 solid lines. And that's a big distinction right away. Notice they're going to be 2 solid lines because they got the little equals to underneath on the inequalities. And I say that because there are going to be some that have the same exact graph but dotted instead of solid. Don't be thrown off by that. No, this has to be solid lines because they're the equal to under my inequality. And my purple is beautifully just right in between them. So for me, it is the first one. And look what I'm saying. You'll see it as I scroll down. Every year this confuses people because they see this pink graph and go, Dylan, there are 2 of them. How do I know what to choose? Well, remember, this is this is dotted lines here, and we want the solid lines. So they are actually 2 different graphs. Not just their colors are different. Also, the graphs themselves. Okay, same thing with this one. This one throws people off. I can see people getting to this point being like, wait, what? Like this one, for instance, doesn't even have any shading at all. So you know that this one can't be right. So everything above 3 and above negative 5, that's going to overlap at everything above 3. Because if I shade everything above this and then everything above this, well, that overlaps up here. You can see very clear purple up here. So we need the dotted lines to be sideways and just the very top to be shaded in. So not this. That's in the middle. That's the wrong direction. Right here, we've got just the top shaded in. And that's what we want. Cool, cool, cool. All right, 7 and 8. We got greater than or equal to 1/4 x plus 4. And we have less than -7/4 x plus 12. Focusing on the blue for the purple. Looks like we're going to be on the left side. Up and to the left. This one. Pink. Okay. And just one more. You can see the breather that takes place here on this assignment. To match up pictures, try and understand what's going on, is so much easier than writing out all the steps for substitution and elimination and recognize when to use one and when to use the other. It's really great. Okay. Give a little breather. Everyone needs a breather sometime. Focusing on the blue. I've got the purple on the left now. This point is going to be 0, -3. That's above. 0, -3 is right here. It's got to be that one. Okay. 8 for 8. The doubles. Wendy's 4 for 4. Wonderful. All right, that's a cool little review of inequalities. Got to see them graphically. Got to see how that connects to our system of equations unit, which is exactly the goal of putting this assignment here. And now we're all done. Best wishes with the rest of your day, whatever you got planned, and I'll see you next time for the next assignment. It's been a pleasure and an honor having you here. Until next time, take care. Bye-bye.